Something strange has just surfaced from the edge of the known universe, so strange, in fact, that even a Nobel Prize-winning scientist is speaking out. The James Webb Space Telescope, humanity's most powerful eye in space, has captured more than just a pretty picture. It found something that doesn't quite fit. Something that wasn't supposed to be there. How could this discovery reshape our understanding of the universe's beginnings? Could it point to a missing piece in the universe's origin story? Or is it a clue that we've been looking at the cosmos the wrong way all along? Buckle up, because the further we look, the further back in time we go. And what we've just seen might not be from the past we expected. At the heart of this discovery is the James Webb Space Telescope, JWST. An observatory that isn't just about gazing at distant galaxies, it's about rewriting the very story of the cosmos. When we talk about looking into space, we're not just talking about distances, we're talking about time travel. The light from the furthest galaxies has been traveling for billions of years to reach us, and JWST allows us to peer into these galaxies as they appeared billions of years ago, when the universe was just beginning to take shape. But this telescope is doing more than just showing us the past, it's challenging everything we thought we knew about the universe. Imagine a telescope so powerful, it can peer deeper into the cosmos than anything humanity has ever created. JWST is not only bigger than its predecessor, the Hubble Space Telescope, but it's also designed to see beyond what we thought was possible. While Hubble captured visible light, JWST focuses on infrared light, which is critical for looking into the earliest moments of the universe. Why infrared? As the universe expands, light from distant galaxies gets stretched into longer wavelengths, known as redshift. This means the light we see from these ancient galaxies is not just distant, it's old. It's stretched out, redder, and requires specialized technology to detect it. That's where JWST's capabilities come in. Infrared light allows us to look farther back in time, beyond the limitations of visible light. We're not just seeing distant galaxies, we're seeing them as they were mere hundreds of millions of years after the Big Bang, a time when the universe was a completely different place. In fact, JWST's infrared abilities make it the perfect tool for observing this crucial moment in the universe's history, often referred to as the cosmic dawn. The telescope's ability to capture these early redshifted galaxies allows us to study the formation of stars and galaxies in ways that were previously unimaginable. To understand just how extraordinary JWST is, you need to know a bit about its design. Its primary mirror, a vast 6.5-meter segmented structure, collects light from far-off galaxies. The telescope is stationed at the second Lagrange point, or L2, located about 1.5 million kilometers from Earth. This position is crucial because it protects JWST from the heat and light of Earth, allowing it to remain incredibly cold enough to detect faint infrared signals from the most distant objects. The multi-layered sunshield keeps the instruments at the right temperature, ensuring they can detect even the faintest emissions from the farthest reaches of space. One of JWST's most significant achievements so far is its deep field image, which has revealed thousands of galaxies in a patch of space that was previously considered empty. But what's really mind-blowing is how these galaxies look, far older and more developed than we had ever predicted. This discovery has rocked the foundations of cosmology. According to the standard models of the universe's evolution, galaxies couldn't have formed so quickly after the Big Bang. Yet here they are, large, complex galaxies, fully formed, shining brightly, and appearing just a few 100 million years after the universe began. Now you might be wondering, how can this be? How can such large, developed galaxies exist so soon after the Big Bang? This discovery forces scientists to reconsider the very way they understand the universe's evolution. If these galaxies are this advanced at such an early stage, what does that say about how quickly the universe is evolving? The standard models of cosmology, which have guided our understanding of the universe for decades, are now being challenged in ways no one could have anticipated. What makes this discovery even more perplexing is the nature of these galaxies. Many of them appear to have already turned nearly all of their gas into stars, a process that, according to traditional models, should take much longer. The formation of stars in a galaxy is not a simple process. It's influenced by factors like supernova explosions and the way matter interacts with the galaxy's environment. Yet, these early galaxies seem to have bypassed many of the obstacles that we thought were insurmountable. It's almost as if they've evolved at a pace far beyond our expectations. This is one of the reasons why JWST's findings are so shocking. They are forcing us to rewrite the cosmic timeline. But the mysteries don't stop there. JWST's powerful instruments, including the near-infrared camera NIRCam, the near-infrared spectrograph NIRSpec, and the mid-infrared instrument MIRI, don't just take beautiful pictures. They provide critical information about the chemistry, star formation rates, and velocities of distant galaxies. The telescope doesn't just show us the galaxies. It allows scientists to examine the light they emit in detail, revealing their internal structures and histories. This has given rise to even more questions. How did these galaxies manage to form so quickly? What processes were at play that allowed them to bypass the normal constraints of cosmic evolution? One of the most profound implications of this discovery is that it challenges the lambda-CDM model, the prevailing cosmological model that describes the universe's evolution. This model, which has been widely accepted for decades, suggests that galaxies formed over billions of years through a slow and gradual process. But JWST's observations are showing us something completely different. These early galaxies seem to have skipped several steps in the process of formation. This is forcing scientists to reconsider not just the details of how galaxies form, but also the fundamental principles that govern cosmic evolution. JWST's ability to peer into the past, beyond the reach of earlier telescopes, is a game-changer. The light from distant galaxies takes billions of years to reach us, and with JWST, we're essentially looking at time travel. Each observation is like a snapshot from the distant past, showing us how galaxies and stars looked when the universe was in its infancy. This ability to see the early universe just a few 100 million years after the Big Bang allows us to trace the origins of stars, galaxies, and the very elements that make up the universe today. JWST is not just a tool for capturing beautiful images, it's a tool for unlocking the mysteries of the universe. It's giving us a glimpse into the distant past, allowing us to see how the first stars and galaxies formed, how they evolved, and how they shaped the universe as we know it. The discoveries it's making are forcing us to reconsider everything we thought we knew about the cosmos. But there's something even more exciting. What if this discovery is only the beginning? What if JWST is just scratching the surface of something much bigger? If these early galaxies are more advanced than we expected, could there be even more surprises waiting for us further back in time? What other mysteries are hidden in the depths of space, waiting to be uncovered by JWST's powerful instruments? The answers to these questions could change everything we know about the universe, and about our place in it. As we look deeper into space, we're not just discovering distant galaxies and stars, we're discovering the very fabric of the universe itself. Each discovery from JWST is a piece of the puzzle, and with each piece, we move closer to answering the most profound questions humanity has ever asked. Where did we come from? How did the universe begin? And what does our place in this vast, infinite cosmos really mean? The more we learn, the more we realize how little we actually know. The universe is far more complex, far more mysterious, than we could have ever imagined. And with each new discovery, JWST is pushing us closer to understanding the deepest secrets of the cosmos. Secrets that have been hidden for billions of years. This is just the beginning. As JWST continues its mission, the mysteries it uncovers will reshape our understanding of the universe and our place in it. What we've seen so far is only the tip of the iceberg, and the journey to uncover the full story of the universe is only just beginning. One thing is certain, the universe is far stranger, far more beautiful, and far more mysterious than we ever imagined. And with the power of the James Webb Space Telescope, we are only beginning to scratch the surface. There was one discovery that truly sent shockwaves through the scientific community. Among the deep field images, astronomers identified galaxies that were not only extremely distant and therefore extremely old, but also surprisingly well-formed. These galaxies had structures, masses, and star populations that suggested they had been around for a lot longer than expected, even though by all accounts they shouldn't have had time to evolve. According to the current model, galaxies take billions of years to mature. So how could something just a few 100 million years after the Big Bang look so grown up? It's like finding a fully grown adult in a maternity ward. This made scientists question whether their understanding of the timeline of the universe was wrong, or whether there's something far more mysterious going on. One such galaxy, let's call it an anomaly of the cosmos, was observed at a redshift of over 13. That means the light we're seeing today left that galaxy when the universe was only 320 million years old. For context, that's just 2% of the universe's current age. And yet, this galaxy wasn't a baby. It was already glowing brightly, filled with stars, actively forming more stars, and boasting a mass that defied explanation. Where did it get all that gas and dust so quickly? And how did it defy the chaotic, turbulent early universe to become so organized? It's like seeing a fully built skyscraper in the middle of an earthquake, when construction was supposed to have just begun. These questions lead to something even bigger. If our models are wrong about galaxy formation, could they also be wrong about other fundamental cosmic events? Could we have miscalculated the rate at which matter clumped together after the Big Bang? Or even worse, are we missing a piece of the puzzle entirely? Some scientists have started to whisper about new physics, about undiscovered forces or particles that could have sped up cosmic evolution. Others suggest we might need to revisit inflation theory, or the way we understand dark matter and dark energy. But none of this is certain. What is certain is that these galaxies shouldn't exist the way they do, and yet, there they are, staring back at us across time and space, mocking our confidence in the models we once trusted. Now, let's pause for a second and reflect on how rare this moment is. Throughout history, science has evolved not just through discoveries, but through contradictions. Every time we thought we had it all figured out, nature would throw a curveball. Galileo's telescope showed moons orbiting Jupiter, defying Earth-centered models. Einstein showed that time and space weren't fixed but flexible. And now, the James Webb Telescope is whispering a truth we didn't expect. That maybe the universe is far more complex, far more alive, and far more mysterious than we ever imagined. That maybe we've just scratched the surface of something far greater than our minds can yet grasp. Even Nobel Prize-winning astrophysicists are beginning to speak out. They're not just excited, they're stunned. Not because they've found answers, but because the questions are bigger than ever. And there's something beautiful about that. Because it means the adventure isn't over. It means the sky still holds secrets. And for every answer JWST provides, it leaves us with 10 new riddles to chase. Imagine standing at the edge of a cliff, looking out into an endless ocean. You've just discovered a new island, one you never thought existed. But now that you've seen it, you can't unsee it. That's what this discovery is. It's an invitation. A cosmic whisper saying, there's more out here. Keep looking. And so, humanity will keep looking. With every pixel of infrared light, we'll chase the origins of galaxies, the first whispers of starlight, the chaotic birth of structure. And maybe, just maybe, we'll learn something not just about the universe, but about ourselves. After all, the universe isn't just out there, it's in us. The atoms in our bodies were forged in the hearts of ancient stars. The calcium in our bones, the iron in our blood, the oxygen we breathe, it all came from explosions that happened billions of years ago. When we study the cosmos, we're studying our own origin story. And if that story is changing, then so are we. So what happens next? Where do we go from here? The next step might be even stranger. Because if JWST keeps finding galaxies that shouldn't exist, the evidence will pile up. And eventually, scientists won't be able to ignore the signs. They'll have to write new models, propose bold new theories, and perhaps challenge the very bedrock of cosmology. Already, some are proposing that time itself may behave differently in the early universe, that quantum effects or new physics could be at play. Others wonder if dark matter has a different role than we thought. Or maybe we've misunderstood gravity at large scales. All of this sounds crazy, until the data starts agreeing. And the data is piling up fast. Every week, JWST sends back new images, new light curves, new spectra. And every now and then, hidden in those signals, is a galaxy that shouldn't be there. It's like a detective finding fingerprints at a crime scene that doesn't fit the timeline. Something doesn't add up, and that makes it even more important to investigate. But let's not forget the emotional side of all this. Because beyond the science, there's a deeply human story here. This telescope, the James Webb, was a dream for decades. It faced delays, budget cuts, political struggles. People spent their entire careers building it, not knowing if they'd live to see it launch. And now, floating a million miles from Earth, in the cold quiet of space, it's giving us gifts beyond imagination. It's reminding us that curiosity still matters, that wonder is still alive, and that sometimes when we dare to look deeper we find not just stars, but meaning. So next time you look up at the night sky, remember, somewhere out there, light from galaxies older than our planet is just now reaching us. Traveling billions of years across time and space, carrying messages from a past we never expected. And thanks to JWST, we're finally learning how to listen. The universe is speaking. And we're just beginning to understand its language. But what if we go even deeper? What if this isn't just about early galaxies or broken timelines? What if we're standing on the edge of a cosmic revelation far beyond our current understanding? Because as JWST peers farther, some scientists are beginning to see not just anomalies, but patterns. Repeated signals. Similar structures appearing in places they shouldn't. It's as if something, or someone, arranged matter in a specific way. A way that keeps defying randomness. A way that hints at design. And while many will stop at physics and evolution, others can't help but wonder, What if intelligence had a role to play in the early cosmos? Now, that might sound outrageous, but think about it. In every discipline of science, whenever we find complexity beyond explanation, we search for cause. Why wouldn't we do the same here? Some theorists suggest we might be seeing the remnants of ancient civilizations, Type 3 civilizations that operated on galactic scales. Could they have influenced early galaxy formation? Could these impossibly mature galaxies be the ruins of something long lost to time? Or maybe they're still out there watching. And suddenly the question becomes even more emotional. Because we're not just looking at light, we're looking for connection. We're trying to understand whether we're alone, or if this vast, dark universe is filled with life, memory, and intelligence far older than our planet. Maybe JWST is more than a telescope. Maybe it's a bridge. A way to connect with something ancient and beautiful beyond comprehension. As the data pours in, scientists are overwhelmed not just with excitement, but with fear. Because they know what's coming. The more JWST sees, the more pressure there will be to rewrite everything. Theories will fall. Textbooks will change. And some will resist. But truth doesn't wait for permission. The universe doesn't care about our comfort zones. It simply reveals itself, layer by layer, photon by photon, until we have no choice but to look again. And what we see might change not just science but how we see ourselves. We've always believed we were at the center of our own story. But what if our story is just one page in a book that began before time? What if the universe has chapters we've never read? Chapters filled with civilizations, gods, or forces beyond imagination. JWST isn't just showing us galaxies. It's opening a book we never knew existed. But here's the most haunting part. For every discovery we make, there's a deeper silence that follows. Because light takes time to travel, everything we see is already gone. Those ancient galaxies? They might not exist anymore. They're ghosts of the past, flickering across the sky. And as we stare at them, we realize we're staring at echoes. At light from civilizations that may have risen and fallen long before Earth was born. That realization hits hard. Because it means that maybe one day someone else will look at our light, our planet, our civilization, and they'll wonder who we were, what we believed, what we left behind. So maybe the biggest gift JWST is giving us is perspective. It's reminding us how small we are, how fragile, how precious. In a universe so vast, filled with countless galaxies, we're just one blue dot, one fragile world holding on to life with trembling fingers. And yet here we are. Building telescopes, asking questions, searching the stars for meaning. That's beautiful. That's heroic. So the next time you feel lost or small or insignificant, remember this: you are made of stardust. Your story began billions of years ago in the heart of a dying star. And now you are the universe, trying to understand itself. Every time you wonder, every time you dream, every time you look up at the night sky, you're continuing a journey that started long before you. And that journey will continue long after. As JWST continues to scan the skies, we'll uncover more secrets. Some will shake us. Some will inspire us. But all of them will remind us of one truth: the universe is alive with mystery. And we're lucky to be part of it. So keep looking. Keep asking. Keep dreaming. Because the stars are listening. And they always have been.